trigonometry and medicine, though worlds apart, are bonded by an invisible yet potent thread of knowledge and comprehension, a testament to the human pursuit of wisdom and understanding. Now how does this all correlate? We are Team Departures.
Howdy, I'm Mark.
What's up? I'm Chloe.
Hey, I'm Basti.
Yo, I'm Nads.
We will show you how the very complicated nature of trigonometry is related to medicine.
One day, Basti, a diligent and tenacious scholar, was working on his studies. From time to time, he was afflicted by headaches. A time came and he had a seizure while on campus. He was rushed to the hospital and underwent an MRI scan. There, captured not one, but 2 tumors nestled within the confines of his brain. The problem here is that MRI scans are not particularly up to scale, and at times, altered. Thus, triangulation had to be employed to find the distance between the two. In regards to trig, radiologists use the formula D equals S, or the length of the first tumor, usually measured in centimeters, multiplied by sine A and B, which are the angles formed when connecting the baselines to the other tumor, all over sine quantity A plus B. However, this method of trigonomic triangulation may also be used by surgeons to locate certain organs and nurses to find and measure certain bodily parts. Given that, the baseline of one tumor up against the skull had a length of 5.2 centimeters, somewhere the middle was a smaller tumor, and if lines were connected to it from both ends of the baseline, it would form 2 angles. Using a protractor, the doctor obtained 53 and 46 degrees respectively. What is the accurate distance between the two? With these measurements, we could easily obtain the accurate distance between them, which is 3.025 centimeters. As we could see from the simple yet revolutionary trigonometric application, information to save Basti and others afflicted is made discoverable. Now, let's see some more examples.
Since Basti had 2 brain tumors, which caused him to have unexpected seizures and falls, the doctors conducted an ultrasound to find his internal jugular vein, on which they would inject apixaban, an anti-blood coagulant, at a 45-degree angle of injection, which was ideal for a subcutaneous injection. The length of the needle injected should be 3.15 centimeters. However, that information would not suffice because the depth is still unknown. The problem here is that the doctors are not particularly sure about the vertical distance of the vein to the skin, since the ultrasound was blurry and not up to scale. The appropriate trigonometric application in this medical situation is the sine function. The trigonometric ratio of sine is equal to the opposite side over the hypotenuse. This trigonometric formula is widely applied in the field of radiology, orthopedics, and neurology. Fundamentally, it is utilized to identify the depth of a bone or the length of the needle that has to be inserted in relation to the appropriate needle angle and degree. More so, it is used to help heal all types of diseases, needle tests, vaccination, and the like. Given that the doctor chose to insert the needle at an ideal angle of 45 degrees or theta and a needle length to insert 3.15 centimeters, which would act as the hypotenuse when an imaginary right triangle is formed. The depth is obtainable. By way of the sine function, we would obtain 2.23 centimeters. Let's see what Basti is up to next.
After being medicated and tested for 2 benign tumors, Basti experienced another seizure as he was walking away from the doctor, causing him to unexpectedly fall and severely fracture his arm. Upon x-raying, the orthopedic surgeon had found that Basti experienced a severe fracture spanning across 3.5 inches using a protractor. It was found that the 2 pieces of bone formed an angle of 15 degrees. Find the optimal size of the plate required to rehabilitate Basti's arm. The equation that is applicable in this medical situation is the trigonometric fraction of cosine. The trigonometric ratio of cosine is equal to the adjacent side over the longest side, the hypotenuse. This trigonometric formula is widely applied in the field of orthopedics and radiology. It is utilized to identify the deviation of a bone in degrees and identify nerve damage. More so, it is used to help heal fractures and prescriptions. With the length of a fracture given, it is quite easy to form a right triangle with 9.14 centimeters as the hypotenuse. Yes, centimeters is also the unit of measurement usually used. Given the fracture angle, we could obtain the length of the adjacent side with the trigonometric function of cosine. From that, we would obtain 8.83 centimeters, or the minimum length of the plate required for Basti's case.
Hi, Mr. Editor here. This truly proved that even the most disparate fields could correlate. Trigonometry is truly revolutionary, and hopefully in the future, they find more applications because that would be great.
That's right, Sen. Trigonometry, aside from the aforementioned, also is used in dermatology and anesthesiology and more. This makes learning trig a lot more fascinating. Sen's right. Finding more applications would mean a better world. It might even help solve a lot of our healthcare problems.
If I break my arm anytime soon, I definitely would ask the doctor for the details and try to solve the plate needed. But seriously, this is genuinely insightful. Despite these being the final output, I will still continue to study trigonometry.
With all of those things happening to me, I definitely learned the most from this group. This shows how trigonometry encompasses even the smallest aspects of our lives, and that is amazing. Despite Naz's last statement sounding iffy, it might be true since trigonometry is so useful.